Everybody can hear me? We're good? Hey, we're good. All right. You probably don't know me, and I probably don't know you for starting out. And you probably don't know that there's much astronomy going on at the University of North Dakota. So I'm here to um, inform you of what we've been trying to do in the past, I'd say since about 2005, to try to improve the type of astronomy that's going on in North Dakota. I'm an associate professor of space studies, as Joe said, and I'm here solely due to Russ and Joe, because Russ actually invited me to this conference to tell you about our doctoral program as we're trying to get new students. First thing, I have handouts. Joe, if you could pass those around. It talks about our doctoral program, and if you have any questions afterwards, feel free to contact me. I also run our observatory, and I guess I would say that I have an official title for this talk. The unofficial title is pretty much what happens when a professor has delusions of grandeur. And this is definitely a work in progress. So, the Department of Space Studies, what the heck is it? There aren't very many creatures like this on the planet, maybe about a half a dozen. We are an interdisciplinary, multidisciplinary master's program. It was started by none other than Buzz Aldrin and David Webb back in 1987. If you recall, in 1986, there was the National Commission on Space report about the future of the space program, which of course went nowhere, but they teamed up with the current dean of my college, John Odegaard, and founded this new type of program. And it's very interdisciplinary. It's not just science, it's engineering, it's all the social sciences. Basically, it gives you a broad background and understanding of everything that encompasses space exploration. The original student population that we sort of aimed for, and I'm second generation faculty, I was not there from the beginning, is mid-career professionals, whether they're in industry, contractors, NASA, the Air Force, what have you. That was sort of our traditional student base, but it's expanded beyond that. So it is a relatively rare type of program. I would say our main competition is International Space University, which is in France. There's also the American Military University and a few other offshoots, but we are, of course, the best. No hubris there. But so it started small, as you would expect, in North Dakota. We served the military bases and students who found out about us. But in 1996, our chair at the time, Chuck Wood, who's now in West Virginia, they came up with the idea of starting a distance learning option program. So it was one of the first online master's programs, and the consequence of doing that is that enrollment went through the roof, at least initially. And how we do distance learning, we certainly are not like the University of Phoenix, which is a three-letter word. And we treat distance students just like campus students. We videotape our class lectures. Distance students see them. They participate in online chats. They do everything campus students do. They can also do thesis work. So we treat them exactly the same, and they are required to do exactly the same and perform at the same level as campus students, whether they do a thesis or not. So in 2001 and 2000, we had pretty much a big faculty turnover. That's how I ended up there. My first knowledge of Grand Forks, North Dakota, which is where we're at, was when I was a grad student at Rensselaer in upstate New York, and I was watching television in 1997. And if any of you know about the history of North Dakota in 1997, 90% of Grand Forks flooded. And I saw on the TV Grand Forks downtown flooded and burning like Dresden, Germany in World War II. And I thought, gosh, I don't want to be there. I've been there ever since. So, hey, you know. So we had a big turnover of faculty. I actually followed my Ph.D. advisor and ended up getting a job in the department. And at that time, we really became a regular academic department with teaching, research, and service. Before then, it was just really a teaching department in every aspect. So we got set up, and in 2004, we started to offer a thesis option for master students. This started with campus students, but migrated to include distance students, although I will say primarily thesis work is done by campus students. I have probably had more thesis students than anybody, and I will say with no doubt that distance thesis students need to be highly motivated, independent, and they need close supervision, obviously, because I don't have said student next to me who I can whip into shape. So I have to do it by other methods, and it takes a lot of effort, but it can be done well. So we chugged on, and last fall we started the Ph.D. in Aerospace Sciences. This is pretty much the culmination of an idea that's been around for a decade plus, finally came to reality, and it's a Ph.D. in Aerospace Sciences because it includes not only our department, but also the Aviation College, which is one of the biggest in the country. It's the big college in our department. So as of today, we have about 150 students. It's the highest enrollment we've ever had. Our enrollment has been going up for the past 4 years without rest at all. We have about 25 to 30 campus students. The rest are distance students. The campus student is your traditional student who's come out of an undergraduate program. And mind you, our students can have a vast variety of backgrounds, whether it's science, engineering, social sciences, what have you. They can have a very, very large, diverse background, and that puts a challenge on us because if we're going to teach them a particular course, we have a student population in the class that has a wide background, but they all have to be brought up to the same level so they understand the material. And that's most relevant for technical courses because students are at different levels. So these might be master's students, but in a lot of ways we have to teach them, treat them like advanced undergraduates because they just do not have the background. As far as research in astronomy, we've focused on a couple of areas. Non-astronomy is spacesuits, planetary spacesuit work that we have an NASA grant. Myself and my faculty advisor, we do near-infrared reflectance spectroscopy of asteroids to derive surface mineralogy of asteroids and try to link that back to meteorite types and the physical conditions in the early solar system. This is for both near-Earth asteroids and main belt asteroids. I primarily work on the main belt, though, myself. I'm starting to dabble in solar physics, collaborating with some researchers down at actually now Kirtland Air Force Base. It was the National Solar Observatory, doing work on sunspot rotations and filaments. And thanks to Russ, we're hoping to add some double star work in our repertoire of capabilities. And my excuse of not floating around but trying diverse topics is I always learn something new. When I went into the solar field, I felt like a grad student all over again, which was painful, but at least I got paid more money. So that was good. So we also have facilities. I'll talk about the observatory. The rest, the other two are run by other faculty in our department. So this is our website. We've been around for 25 years. If you want to check it out, it's just space.edu, and you can take a look at it, and it tells everything you need to know. So focusing on the astronomy as far as what has been going on. I would say before 1991, the state of North Dakota had a relatively sparse history in any type of astronomy whatsoever. A couple of small observatories. UND had one back in the 50s. Minot State has one that doesn't work. That's about it. 1992, in a little plot of land about 10 miles west of Grand Forks, the Planetary Science Observatory was established. Had an 18-inch Newtonian that was used for star parties, and about 1996, the first internet-controllable telescope was built. When I arrived in 2001, it didn't work, if that tells you anything. So some students attempted thesis work with the old observatory, didn't quite work. And so then I arrived on the scene, and part of my job as being hired was to get the observatory working. Now, mind you, my background is geology, and I actually have a degree in political science. So I learned a lot since my doctoral program, more than I would ever have imagined. So, being one with delusions of grandeur, I thought, well, these are dinky little telescopes. Let's have a meter-class observatory in North Dakota. We did a feasibility study, about $4 million to get a DFM 1-meter scope. However, I learned very quickly that in North Dakota, there was no money for science of that scale. Of course, I've learned since then, or I've figured out since then that actually if I get money for a 1-meter class observatory, I'm not going to put it in North Dakota. because there are too many limitations in how much work you can do. So I rejiggered my priorities and said, okay, if we can't have a big observatory, we will have multiple small internet controllable telescopes. So the sequence from 2005 until last year is pretty much right there. One of the best skills I've been able to cull during that time is finding money. Finding money from other sources, whether it's from the college, my department. I don't know how many of you are familiar with EPSCoR, the experimental program to stimulate competitive research. We got some money from them, and a few private donations of modest amounts. So if we went from one non-functional internet observatory to 3 functional ones, and I mentioned this trailer here in 2010. I mentioned that because prior to that, we were using a dilapidated, mouse-infested, old air traffic control trailer as a safe space that if you put it next to the administration building on campus, it would have been gone in 5 minutes. But if this was 10 miles west of town, so we had to suffer through this until I convinced the dean that we needed something that was actually civilized. So that was good because we needed a sort of a control center for all of our telescopes. And last year really is when we started to transition from renovation to operations. And so we're doing asteroid photometry programs, which is going to be long term. We started some solar observing, and we commissioned a stellar spectrograph in addition. So we're developing a lot of different capabilities that make this really a well-rounded training facility for students in the state, because students in North Dakota have very little exposure to astronomy whatsoever. So this is a nice aerial view of our little plot of land that's situated on about 1,000 acres of biology land that the university manages. This is the first internet controllable telescope that I renovated with a 16-inch scope. Here's the second one with a 10-inch scope. Here's the third one with a 16-inch scope. This is that old horrible trailer that I mentioned that's been replaced, and it's about a 140 by 140 foot area. That's nice and compact, and we have a wireless internet there. We have a security system. We've really built it up over the past 7 years where it's actually being utilized more now than it's ever been. Now, I got this yesterday. I was looking at dark sky maps of North Dakota, and Grand Forks is here. Canada's up here. Fargo's down here. We're about right here. But the interesting thing is the white blob. The white blob is from all of the oil development in North Dakota. We make more oil than Oklahoma now, and it's non-trivial. So formerly fabulous dark sky is now blotted out, but fortunately we're not there. We're over here, and we still have decent skies where we are. This light pollution from Grand Forks affects us to the east only up about 30 degrees. Then we have an Air Force base to the northwest. That's pretty trivial light pollution, so that's not an issue. So on dark nights, on moonless nights, we still get the Milky Way, naked eye, which is pretty good. Here are the 3 scopes. All of them now have paramounts, which is much better than what I originally had, which were Meade fork mounts. We have apogee cameras, SPIC cameras, and a fly camera that we use, whether it's both for nighttime work or daytime solar imaging. I'm getting some interline cameras that are going to be used for the solar work. And pretty much we are about 80 to 90% on the way for totally robotic operation, although I'm really not terribly keen on doing that because I use this as a training facility and I want students there. I want them to get their hands on the equipment because that is really the way to learn. And so that's why total automation is not my top priority. Getting students actually handling hardware and looking at data is the biggest priority. I do have a goal of adding a 24-inch scope on site, but that's going to make me find $100,000 or so. So that's going to take a bit of an effort, but it's certainly doable. So for professional research, again, I mentioned the solar physics, the sunspot rotation research. I have an NSF proposal funding. More asteroid work with vestoids, and if you don't know what a vestoid is, they're fragments of the asteroid Vesta, thought to be, that I'm going to resubmit using data from WISE. And of course, at our observatory, do long-term asteroid photometry. We can also do variable star photometry and such. And one thing I found in the solar field, which is interesting, as far as regions of the spectrum that are used to observe the sun, is H-alpha work is for the chromosphere, and there aren't many instruments that observe the chromosphere regularly. There are a few, but there aren't a lot. And so we're going to do long-term imaging, both full disk and high res on particular active regions, and see what we can get. But let me, before I run out of time, I want to get to our Ph.D. program. But here's just a list of things we're going to be doing this year and such. I teach a 400 level observational astronomy course. That's on the bottom. Students get actual observing time during this course. Thesis students also use the observatory, as well as non-thesis students. And having 3 scopes actually is very helpful for class, because obviously we can run them all at the same time, and the students get more time on the scope. So, again, one big message that I want to take away, you to take away from this, is that I'm looking for collaborations with other institutions significantly, because that's really one way we can grow and diversify our capabilities. So if you have an interest in collaborating with wannabes like us, please talk to me. So on to the PhD program. The canonical mission statement on top: to provide interdisciplinary teaching and research at the highest academic levels, to provide highly educated scholars and leaders with the skills necessary to mix technology and science with an understanding of politics and economics of the aerospace fields. For us, looking for research grants in astronomy, of course, we can't do the science if we don't have the funding, and that involves politics. To get into the program, you need a master's degree from an accredited school, GPA of 3.25 plus, standard stuff, personal goal statement, CV. You have to take the GRE general exam, and industry experience is preferred but not required. For the GRE general, there's no specific minimum score required, but we do need you to take it. And so it's sort of in a sense that it mirrors other PhD programs. You need to do 60 credits beyond the master's. You can do up to 18 dissertation credits, have a qualifying exam, and you have your your core courses and your scholarly tool courses, which basically are introductory courses and research method courses that apply to all people. Because again, we're going to have students from not just the sciences, but also in the humanities. So there's going to be some commonalities, but regardless of what you do. Now, for distance students who want to do a doctoral degree, they have to be on campus 1 week, got it, per year. And the key for this, I didn't devise this program myself. I could admit that I would do it slightly differently. But after you take away all the requirements, there are about 20 to 32 credits left that you have to take, however you add these up. So how do you get whatever your research is, let's say it's double star astronomy or whatever, how do you get the right courses? Well, these are the courses that deal with astronomy and planetary science currently in our department. If you're going to do a double star or a stellar astronomy dissertation, these don't really apply much. So what do? It really means we have to build a custom set of courses that are appropriate for the particular student, and there is a way to do this. That is with our Space Studies 570 option, which originally was designed for new or experimental courses. However, working with the student, we can devise an appropriate set of courses to take that are appropriate, whether somebody is doing solar physics or stellar physics or asteroid research or whatever. And that's really important, because the student really needs to have the right background. They can't just take peripheral courses that aren't really related to what they're doing. So this is the strategy, at least I'm going to approach, for students who are going to be accepted into our doctoral program. So, a few things to remember. We only admit students in the fall semester. The deadline is February 1st annually. Funding is going to be a big challenge. I am perpetually submitting grants now to fund doctoral students, and I'm not going to stop until I get funded. And other faculty are trying to do the same. But in the meantime, distance students who don't require funding will probably be ahead of the pack, all other things being equal, if they qualify in every other way. So this is obviously new. We're just getting it started. We only have one student in the doctoral program right now, but that's obviously going to increase. But to do that, we certainly need the money and we need the commitment. And I will just skip that. And that's it. Thanks very much.